This is B. Ramarao from SRRS Government Polytechnic, Silsila. Today we discuss first year, first semester in diploma students. Common subject, general chemistry, general chemistry. Subject code C104. Today we discuss molarity, normality and colloids. Molarity, normality and colloids. Objectives. On the completion of this period, you would be able to know. On the completion of this period, you would be able to know molarity, normality, calculation of molarity and normality, colloids, types of colloids. On the completion of this period, you would be able to know what is molarity, how to calculate the molarity given substance, normality, what is normality, how to measure normality given solution, calculation of molarity and normality of the substance, colloid, what is colloid, how many types of colloids, what are the importance of colloids, we discuss in this hour. What is molarity? Why molarity we are finding in a given solution, we discuss in this hour. Ways of expressions, concentration of solution, molarity. Molarity. Molarity is the number of moles of the solute present in 1 liter of the solution. Molarity is the number of moles of solutes present in 1 liter of solution is called molarity. The number of moles of solutes present in 1 liter of solution is called molarity. Number of moles means the Avogadro number of particles present is called mole. The Avogadro number is a constant value 6.023 into 10 to the power of 23 particles, atoms or moles present is called mole. These how many number of moles of solutes present in given 1 liter of solution is called molarity. Molarity is denoted by capital M. Capital M is equal the number of moles of solutes by volume of solution in liters. Therefore, small n by V in liters. Small n by V in liters. N means number of moles by volume of solution in liters. Molarity of a solution is equal number of moles of solute by number of volume of solution in liters. Therefore, molarity M is equal number of moles of solute by volume of solution in liters. Molarity of a solution is equal number of moles of solute by number of volume of number of liters of solution or volume of solution in liters. Therefore, M is equal small n by L, capital L, small n indication number of moles absolute by volume of solution in liters. Molarity is expressed as moles of solute per liter of solution. Is expressed as moles of solute per liter of solution. Molarity describes concentration in terms of concentration in terms of volume of solution, volume of solution, not volume of solvent. Therefore, molarity is equal to number of moles of solute by volume of solution in liters. Volume of solution. Molarity is expressed as moles of solute per liter of solution. Molarity describes concentration in terms of volume of solution, not volume of solvent. Therefore, molarity is equal to number of moles of solute by volume of solution in liters. Volume of solution in liters. Molarity calculation of number of moles of solutes present in given 1 liter of solution is called molarity. For example, what is the molarity of 0.0 moles? 0.40 moles of NaCl dissolved in 0.25 liters of water. 0.25 liters of water. What is the molarity of a 0.40 moles of NaCl dissolved in 0.20 liters of water? Therefore, number of moles small n is equal to 0.40, volume of solution in liters 0.250 liters. Calculation molarity is equal to how much? Therefore, molarity is equal to number of moles of solute by volume of solution in liters. Molarity m is equal to 0.40 by 0.250. That is equal to 1.6 m. 1.6 m moles per liter NaCl present given 0.40 moles of NaCl dissolved in 0.250 liters of water. Normality. The strength of solution measured in terms of gram equivalent per liter is called normality. The strength of solution measured in terms of gram equivalent per liter is called normality. It is denoted by capital N. The strength of solution measured in terms of gram equivalent per liter is called normality. It is denoted by N. A solution having 1 gram equivalent of the dissolved solution solute in 1 liter of its solution is called normal solution. A solution having 1 gram equivalent of the dissolved solute in 1 liter of its solution is called normal solution. The strength of solution measured in terms of gram equivalent per liter is called normality. It is denoted by capital N. A solution having 1 gram equivalent of the dissolved solute in 1 liter of its solution is called normal solution. Normal solution. A solution having 1 gram equivalent of the dissolved solute in 1 liter of its solution is called normal solution. What is gram equivalent? The weight of the substance. the weight of the substance that react with 1 gram of hydrogen or 8 grams of oxygen or 35.5 grams of chlorine is called gram equivalent weight of the substance. Normal expressed as a ratio of the amount of solute to the total amount of solution. Expressed as a ratio of the amount of solute of the total amount of solution. Normality. It is defined as the number of equivalents of the solute, gram equivalent of solute, present in 1 liter of solution is called normality. Therefore, the gram equivalent weight of solute by the volume of solution in liters. Mass of amount of solutes. It is defined as number of equivalents of the solutes present in 1 liter of solution. Gram equivalent weight of the substance present in 1 liter of solution is called normality. Concentration is equal to amount of solute by total amount of solution. Amount of solute by total amount of solution is called normality, expressed as a ratio of the amount of solute to the total amount of solution. It is defined as number of equivalents of the solutes present in 1 liter of solution is called normality. Concentration is equal to amount of solute by total amount of solution. Concentration in terms of weight by volume, mass of units in grams. Normal. Calculation of equivalent weight. What is equivalent weight? The weight of the substance that react with 1 gram of hydrogen is called equivalent weight of the substance. Weight of the substance that react with 1 gram of hydrogen is equal to equivalent weight of the substance. Equivalent weight of the substance calculated by given below formulas of acids, bases. Acids and bases. Equivalent weight of acid. The ratio between the ratio between gram molecular weight of acid and its basicity is called equivalent weight of acid. The ratio between molar mass of the acid, that means gram molecular weight of acid and its basicity of acid is called equivalent weight of acid. Acid equivalent weight are measured by using given formula is equivalent weight of acid is equal to the ratio between gram molecular weight of acid and its basicity. What is basicity? The number of replaceable H plus ions in 1 mole of an acid is called basicity. The number of replaceable H plus ions from acid is called basicity of acid. The number of replaceable H plus ions from acid is called basicity. Like basicity of HCl is equal to 1, that is equal gram molecular weight 36.5 by 1, that is equal to equivalent weight of HCl is equal 36.5. Equivalent weight of H2SO4 gram molecular weight 98, basicity of H2SO4 2. H2SO4 replace 2 H plus ions from 1 mole of H2SO4, then basicity of H2SO4 2, 98 by 2 is equal to 49. Equivalent weight of H2SO4 is equal to 49. Equivalent weight of acid is equal to gram molecular weight of acid by basicity of acid. What is basicity? The number of H ions replaced from acid is called basicity. Equivalent weight of base. The ratio between gram molecular weight of base and its acidity is called equivalent weight of base. What is equivalent weight of base? The ratio between gram molecular weight of base and its acidity is called basicity. Acidity is called equivalent weight of base. What is equivalent weight of base? Molar mass of the base by acidity of the base. What is acidity? The number of OH minus ions. How many ions? The number of hydroxyl ions replaceable from 1 mole of base is called acidity. The number of hydroxyl ions replaced from base is called acidity of base. For example, sodium hydroxide. Sodium hydroxide, it is replaced only one OH. So, sodium hydroxide gram molecular weight 40 by 1. Therefore, equivalent weight is equal to 40. Equivalent weight by 40. Magnesium hydroxide MgOH taken twice. Magnesium hydroxide. Magnesium hydroxide acidity is equal to 2 gram molecular weight of magnesium hydroxide by acidity of magnesium hydroxide. Magnesium hydroxide replaces 2 OH minus ions from 1 mole of magnesium hydroxide, so acidity of magnesium hydroxide is 2. Magnesium hydroxide gram molecular weight magnesium 24 to oxygen 32 plus 2. Total 58. 58 by 2 that is equal 58 by 2 that is equal 29. Equivalent weight of magnesium hydroxide 29. Equivalent weight of sodium hydroxide 40. Calculation of equivalent weight of substance. Calculation of equivalent weight of substance. Molarity. Molarity is a concentration unit that describes how much of a substance is dissolved in a solution. Molarity is equal number of moles of solute by volume of solution in liter. Therefore, units of molarity moles per liter. Units of molarity moles per liter. Molarity calculation. Given problem. What is the molarity of 250 ml of solution containing 0.35 moles of NaCl? What is the molarity of a 250 ml of solution containing 0.35 moles NaCl? Given data, number of moles small n is equal to 0.35, volume of solution in milliliter, that is 250 ml. First converts milliliters to liter of the solution. 250 ml into 1 by 1000, that is equal to 0.25 liters. Milliliters of the solution convert to liter, 0.25 liters. Number of moles of NaCl 0.35 moles. Now calculate the molarity of solution. Molarity is equal to number of moles of NaCl by volume of solution in liters. 0.35 moles of NaCl by 0.25 liters of solution. That is equal to 1.4 moles per liter NaCl present, given 0.35 moles of NaCl present in 250 ml of solution. What is the Molarity of a 250 ml of solution containing 0.35 moles of NaCl. First, milliliters and the solution convert to liters, therefore 250 into 1 by 1000, that is equal 0.25 liters. Given number of moles of NaCl 0.35 moles. Now calculate the molarity of the solution. Molarity is equal number of moles of NaCl by total volume of solution. 0.35 moles of NaCl by 0.25 liters of solution, that is equal 1.4 m NaCl. Suppose we have 35 ml of we have 35 ml of 0.85 m capital M molarity magnesium chloride solution. How many moles of magnesium chlorides are present in the solution? 0.85 m capital M molarity. Volume of solution 35 ml. Calculate the number of moles small n how much? 35 ml of solution convert to liters. Milliliters to liters. Convert milliliters to liter 35 ml into 1 by 1000 ml. That is equal 0.035 liters. 0.035 liters. Molarity of solution 0.85 m. Calculate the number of moles small n is equal to how much? Now rearrange the molarity equation and solve for moles. Therefore molarity is equal to number of moles of solute by volume of solution in liters. Capital M is equal to small n by capital L in liters. Therefore, number of moles N is equal molarity into volume of solution in liters. Volume of solution in liters. Therefore, number of moles is equal to molarity 0.85 m into 0.035 liters 0.85 moles per liter, therefore 0.85 0.85 moles per liter, liter cancel, 0.035 into 0.85, that is equal 0.030 moles magnesium chloride. 0.030 moles of magnesium chloride dissolved in 35 ml of solution, then form 0.85 m magnesium chloride solution. Suppose we have 35 ml of 0.85 m magnesium chloride solution. How many moles of magnesium chlorides are present in the solution? 35 ml of solution convert to the liters, that is 35 into 1 by 1000 ml 0.035 liters. Therefore, molarity is equal number of moles by volume of solution in liters. Number of moles is equal molarity into volume of solution in liters. 0.035 liters into 0.85 moles per liter, liter cancel, 0.035 into 0.85 moles, that is equal 0.030 moles magnesium chloride. How many milliliters of 1.2 m magnesium chloride solution are needed to have 0.35 moles magnesium chloride? How many milliliters of 1.2 m magnesium chloride solution are needed to have 0.35 moles magnesium chloride? Moles, molarity, then calculation volume of solution. Molarity of magnesium chloride is equal to 1.2 m. Number of moles of magnesium chloride 0.35 m. Calculate the volume of solution in milliliters. In milliliters. Capital M is equal 1.2, small n is equal 0.35, volume of solution V in liters. Volume of solution in liters convert to the milliliters. Rearrange the molarity equation. Molarity is equal to number of moles by volume of solution in liters. Therefore, volume of solution in liters is equal to number of moles of solute by molarity. Number of moles of magnesium chloride 0.35 by molarity 1.2 moles per liter. Therefore, 0.35 by 1.2 is equal to 0.29 liters. 0.29 liters. Then convert to liter to milliliter. 0.29 liters into 1000 by 1000 ml by 1 liter. Liter cancel. That is equal to 290 ml of magnesium chloride dissolve 0.35 moles, then form 1.2 m magnesium chloride solution. 0.35 moles of magnesium chloride dissolved in 290 ml of solution, then form 1.2 m magnesium chloride solution. 1.2 m magnesium chloride solution. Dilution example solution. Dilution example solutions. How many mLs of 2.5 m HCl stock solution would be read to remove 100 ml 0.8 m HCl solution? Concentrated solution to dilute solution by adding water. Dilution law. How many ml of 2.5 m HCl stock solution would we need to make 100 ml of 0.8 m HCl solution? Concentrated solution molarity 2.5 m, changing molarity 0.8 m, changed molarity quantity of solution 100 ml. How many mLs of 2.5 m HCl solution? Therefore, M1 V1 is equal to M2 V2. M1 V1 is equal to M2 V2. M1 concentrated solution molarity, V1 concentrated solution volume, M2 is equal dilute solution molarity, V2 final volume of solution. Final volume of solution. Therefore, M1 V1 is equal to M2 V2 2.5 M into V1 is equal to 0.8 M into 100. Therefore, V1 is equal to 0.801 M into 100 by 2.5. That is equal to 32 N. 32 N. 32 N. So, V1 is equal to 32 ml. 32 ml of 2.5 m HCl dissolve in 100 ml of solution, then form 0.8 m. How many milliliters of a 2.5 m HCl stock solution would we need to make 100 ml of 0.8 m HCl solution? Therefore, M1 V1 is equal to M2 V2. M1 concentrated solution molarity, V1 concentrated solution volume, M2 diluted solution molarity, diluted solution volume V2. 2.5 m into V1 is equal 0.80 m into 100 ml. Therefore, V1 is equal 0.80 m into 100 ml by 2.5 m. Molarity cancel, that is equal 32 ml. 32 ml of 2.5 m HCl dissolve in 100 ml of solution, then form 0.8 m solution. Therefore, dilution is the process of adding solvent to a more concentrated solution to yield a solution of lower concentration. The equation of dilution calculation is M1 V1 is equal to M2 V2. Here M1 is initial molarity, V1 is the initial value, M2 is the final molarity, and V2 is the final value. Dilution law. Dilution is the process of adding solvent to a more concentrated solution to yield a solution of lower concentration. The equation for dilution calculation is M1 V1 is equal to M2 V2, where M1 is the initial molarity, V1 is the initial value, M2 is the final molarity, and V2 is the final value. Problem. What is the molarity of 1NH2SO4 solution? Normality to molarity. In this case, N factor is equal to 2 since there are two H plus ions replaced from H2SO4. Therefore, molarity is equal to normality by 2. Molarity is equal to normality by 2. Therefore, normality is equal to basicity into molarity. Basicity is equal to 2. Therefore, molarity is equal to normality by 2. 1 by 2, that is equal to 0.5 m. The relation between molarity and normality is equal. Therefore, normality is equal to basicity into molarity of basicity into molarity. Therefore, 1 by 2, 0.5. What is the normality of a solution of H2SO4 having a molarity of 0.100 n? N factor is 2. Again, 2 H plus ions replace. Therefore, normality is equal density into molarity. Density into molar. 2 into 0.100, that is equal 0.200 n solution. Therefore, normality is equal density into acid molar. Colloids. A colloid is a substance. Colloid is a substance microscopically disappeared through another substance. The word colloid comes from a Greek word kolla, which means glue. Thus, colloidal particles are glue-like substance. These particles pass through a filter paper but not through a semi-permeable membrane. What is a semi-permeable membrane? A membrane which allows only solvent molecule through it is called semi-permeable membrane. Membrane which allows solvent molecule through it is called semi-permeable membrane. A colloid is a substance microscopically disappeared throughout another substance. The word colloid comes from a Greek word kolla, which means glue. Thus, colloidal particles are glue-like substance. These particles pass through a filter paper but not through a semi-permeable membrane. Colloidal is a substance microscopical disappear throughout another substance. This colloid comes from Greek word which means glue. Thus, colloidal particles are glue-like substance. These particles pass through a filter paper but not through a semi-permeable membrane. Semi-permeable membrane. Colloidal presents two substances, a dispersed phase dispersion medium. These present two components, one is dispersed phase, another one is dispersion medium. Dispersion phase, discontinuous phase, dispersion medium, continuous phase, discontinuous phase, continuous phase. A dispersion phase, dispersion medium. Dispersed phase, dispersion medium. Dispersion medium. A dispersed phase. Particles have a diameter between approximately 1 nanometer to 100 nanometers. These yellow color particles, yellow color name is blue color particles, approximately 1 nanometer to 100 nanometer particles are called dispersed phase. A dispersed phase particles have a diameter of between approximately 1 nanometer to 100 nanometers. Such particles are normally invisible in an optical. Though their presence can be confirmed with the use of ultra microscope or an electron microscope, alpha microscope or electron microscope. Dispersion is as a particle's diameter between 1 nanometer to 100 nanometer. Such particles are normally invisible in an optical, though their presence can be confirmed with the use of alpha microscope or electron microscope. Based on nature of interaction between dispersed phase and dispersion medium, colloids are two types: lyophobic and lyophilic colloids. Lyophobic and lyophilic colloids. These are colloids presents two components: dispersion phase, dispersion medium. These solutions are classified two types: lyophilic colloids, second one lyophobic colloids. Lyophilic colloids. Lyophilic colloids. Colloidal solution in which the dispersed phase has a greater affinity for the dispersion medium. The strong attraction between dispersion phase and dispersion medium's colloids are called lyophilic colloids. The dispersion phase and dispersion medium both are strong attraction to each other. Colloids are called lyophilic colloids. They are also termed as termed as intrinsic colloids. Intrinsic colloids. Such substances have tendency to pass into colloidal solution when brought in contact with dispersion medium. If the dispersion medium is water, they are called hydrophilic or emulside. Emulsides. The lyophilic colloids are generally self-stabilized, reversible in nature, and are heavily hydrated. Example of lyophilic colloids are starch, gelatin, rubber, protein, etc. Lyophilic colloid solution in which the dispersion phase and greater affinity for the dispersion medium. They are also termed as intrin- intrinsic colloids. Intrinsic colloids. Such substances have tendency to pass into colloidal solution when brought in contact with dispersion medium. If the dispersion medium is water, they are called hydrophilic colloids. The lyophilic colloids are generally self-stabilizer, reversible in nature, and are heavily hydrated. Example of lyophilic colloids are starch, gelatin, rubber, proteins, etc. Lyophobic colloids. Lyophobic colloids. Colloidal solution in which the dispersion phase have no affinity to the dispersion medium. Colloidal solution in which the dispersion phase has no affinity to the dispersion medium. The weak attraction between dispersion phase and dispersion medium. There are also referred to extrinsic collides. Extrinsic collides. Such substances have no tendency to pass into colloidal solution when brought in contact with dispersion medium. The lyophobic colloidals are relatively unstable. They are irreversible by nature and are stabilized by adding small amount of electrolyte. They are poorly hydrated. If the dispersion medium is water, the lyophobic colloids are called hydrophobic or suspenoids, suspenoids colloids. Example, soils of metals like iron, silver soil of metal hydroxide, and soil of metal sulfates. Lyophobic colloid particles, lyophilic colloidal particles, colloidal solution in which the dispersion phase has no affinity to the dispersion medium. There are referred between dispersion phase and dispersion medium. Such substances have no tendency to pass into colloidal solution when brought in contact with dispersion medium. The lyophobic colloids are relatively unstable. They are irreversible by nature and are stabilized by adding small amount of electrolyte. They are poorly hydrated. If the dispersion medium is water, the lyophobic colloids are called hydrophobic or suspenoids. Example, soils of metals like iron, silver soil of metal, hydroxide soils of metal, hydrophobic colloids. In this hour, we discuss about what is molarity, what are the units of molarity, what are the formula of molarity, how to calculate the given solution molarity or given solution number of moles or given solution value. What is normality? What are the units of normality? How to calculate the equivalent weight of acid, base by using acidity and base. Calculate the normality of given solution. Calculate the volume of solution of given normal solution. Calculate the equivalent weight of given normal solution. What is a colloid? What are the components present in a colloids? How many types of colloids? These are two types. One is hydrophobic, lyophobic, and second one is lyophobic and lyophilic colloids. Lyophilic and lyophilic colloids. These are discussed in these topics. Thank you. Thank you once again.